I hope that makes sense. And then here's the trick. I love this trick. I use it all the time. If you want the player to do what it just did again, what you need to do is find a way to pass this function in here. So transition has a argument called onComplete, and normally people pass in like function, do something, end, right? Like that. But people forget, and I mention it on the show a lot, is that if the enemy has a field on it called onComplete, then you can just simply pass in, and I should have said here is self. You can simply pass in the thing you're operating on. So if you're operating on this and it has a field or a function called onComplete attached to it, then when transition gets done, it'll say, hey, look, you passed in onComplete, and by the way, there's a function on that guy, this object, called onComplete. I'll run that. And so here I've called it move to player because I want to call it later, but then I simply say enemy onComplete is equal to, and I pointed at move to player. Move to player takes an argument self, and so when this onComplete call is executed, it runs the same function again, which is the one that just transitioned it. So you get this looping transition. It's transition, complete, run another one, do the calculation again, continue, forever.
The only time you'd ever want an infinite loop.
Yeah, this is, it's an infinite loop, but not in the sense that it operates every frame. So this is the nickel version of AI. The 10 cents version is simply doing a transition, but only going part way. So instead of trying to walk all the way to the player, use that vector information and calculate a point someplace between yourself, the enemy, and the player, and then calculate that distance, walk to that point, and then continue. So in other words, walk a shorter distance, and then check again to see if you need to change direction.
Okay, I want to point out one thing while you're here that it's probably obvious to a lot of people, but it may not be obvious to somebody who's brand new to this, to creating games. And that is that at this point you're moving the player, but you're also somewhere else in the code you are flipping through those individual frames that make the player look like they're walking.
Right.
So, like right there, yeah, you say play, angle, animation, walking, and then it's probably somewhere in the code. It's actually making the player appear to be walking, but the player would be stationary unless you moved him. And then when you, in the combination of transitioning and frame animation, that's where it actually looks like it's walking.
Exactly.
And I don't think those things are ever always put together, and it just seems like worth noting.
The cool thing about this game, not to give myself accolades, but useful to other people, is that the player uses the Reiner animations, the enemies use the Reiner, everything's using the Reiner animations. And almost all of these Reiner animations that I'm using for the moving good guys and bad guys have the same sort of like layout. They have the same organization. And so what I was able to do was to create this module, which I showed you guys before, called Sprite Maker. And Sprite Maker is sort of like a generic loader player, which then, in any one of these, for example, the green zombie maker, I require Sprite Maker, and then I use it to build up the sprite sheets and to create the characters. And then if I need to, for example, let's look in Arrow Maker. I think that's an example that I did something different. So Arrow Maker, no, I'm not going to be able to find one. Sorry, trying to give you a good example here. But I was going to say, I can't find it right now, but one of these makers uses the Sprite Maker method to load, but then it needed to do something different when I played it. So I wrote my own local create. So I didn't call the one for Sprite Maker, I made my own. So what I've done here is like a poor man's object-oriented code. It's not really object-oriented, but what I did was I leveraged a module over and over for doing common work. And then when a specific instance needed to be a little bit different, then I coded it myself the special way. So,
let me ask you. You said you were working with these pre-existing sprite packs and stuff, so the timing has already been kind of worked out for you in terms of what the player's what the character's stride should be and things like that. Is there any ever a point where you can get out of whack where the player looks like he's sort of gliding across the screen when not actually walking across the screen?
Absolutely. Balancing the in fact, let's go back to the game, and I'll just
Sorry,
show
I don't want to derail, but it feels like these are important.
That's an excellent question. So let's look at these guys. They all look like they're moving at a good rate. Let's see if we can get a guy to come on screen who's moving super fast. Let's just keep killing them until they're fast. Or we could do that. We could find a way to crash the game in the demo. So here's one. At an angle, this green zombie looks, it's probably going to be really hard to tell. You're going to need to play with this for a while. But basically, when they move
the
too
hangout
far,
frame rates are
terrible
too.
I'm just going to change the speed so we can see this more clearly.
Yeah, the hangout frame rates, probably terrible too, because as we move, the characters are skipping around on the screen.
Yeah, sorry. So here, I'm going to rerun it now that they're going to be moving way too fast. So I'll just let it run over and over. So you can see, even now, they look pretty good. But what I encourage people to do is go to line 161 in the enemy manager and pump up the speeds to be really ridiculously high, from 75 to 275. And then in answer to your question, what you're going to see is that the speed at which the guys are moving does not match the rate that their legs are moving. They look like they're, as you say, gliding. They're sort of moving their legs, but they're sort of like ghosting it over the ground, right?
Yeah.
So we haven't dealt with, there's a solution to this which I have not implemented yet, and the solution to that is any individual object that is playing a sprite animation, you can change the time scale for that particular object. And so what I would do in that case is I would have a base scale. So let's say 100 is our base speed that I get the animation just right for. But then let's say the speed is 150. I could simply give it a factor of 1.5 and change the animation scale for this instance of this player so that it would play its own animation faster so that it seemed to match the rate at which the enemy was walking.
So let me say that back to you. So I know I'm clear. So what you're saying is that we have a rate at which we flip back and forth between these individual frames of a sprite, and then we also have the speed at which we move those sprites from, let's just say, one side of the screen to the other, and we can adjust either one of those values to try to walk in, no pun intended, try to walk in the visual effect.
Right. So